Today I'm going to try my best to perform a torch assay using the Butler Torch Assay method. This is designed to be used in the field or in a small lab, and it is designed to take the place of a commercial fire assay, according to Mr. Butler. This is the material that I am going to be assaying. This is a quartz matrix with some galena trapped in it. And this is the sample that I'm going to crush to use for my fire assay. I do know that this material contains some values. I do know that the material from the vein that contains sulfides, and this does not contain sulfides, has a much higher concentration of values, so I'm not sure what I'm actually going to get out of this. All I'm looking for at this point is the presence or absence of a metal bead or prill at the end of the assay. I plan on going back up and removing more material from the vein that is rich in sulfides, but I happen to have this sample in the car, so I figured I would do the fire assay. So this is the tools and equipment that you need to perform a fire assay. I have an oxygen and acetylene welding tank system and a Victor J28 torch that has a double-aught nozzle on it. Mr. Butler had recommended a triple-aught nozzle, but I find that that is too difficult to deal with because it doesn't allow enough gas to come out without extinguishing the flame. The assay is performed using a charcoal crucible. The charcoal burns during the assay procedure, creating gas which helps to protect the sample, and it adds carbon to the assay. This is the cupel, where we will try and determine if a bead is present. Mr. Butler has formulated this assay flux to use. This is borax glass. I'm going to crush this sample using a ceramic mortar and pestle. If I were worried about contamination, I would clean the mortar and pestle, probably with a little bit of quartz sand. A couple of notes regarding safety. You notice I have a fan blowing fumes away from me. The flux material contains lead in the form of litharge. Lead fumes are deadly. Galena contains lead in the form of lead sulfide. That's deadly. Ore in general contains metal. Anytime metal is volatilized, there are fumes. The fumes are toxic. Don't breathe the fumes. The torch itself reaches temperatures in excess of 3,000 degrees. It will melt just about anything in the crucible. The combination of the ore, the flux, and the borax, when melted, turn into a liquid slag, which is extremely hot, and it would be very dangerous to get it on your skin. So as you can see, I am crushing the sample using my mortar and pestle. The idea is to crush it to about 100 mesh. It takes a little bit of time, a little bit of patience. We're starting to get there. Say that's good enough. Okay, a couple things you'll notice. These are my tongs, this is my crucible. Because this is an assay, the components of the assay, meaning the ore sample, the flux, and the borax, need to be measured out in precise proportions. In order to do that, we have a measuring spoon that Mr. Butler provided. We are going to measure one packed spoonful of the ore sample and place it into this cup. Here's your packed spoonful into the cup. This is your second measuring spoon. It's about 4 times the volume of the first measuring spoon. We are going to take one heaping spoonful of the assay flux and place it into the cup with the ore sample and mix them together. One heaping teaspoon. Mix well. I am then pouring it into the crucible. It's a lot like baking a cake. Now we are going to take one large spoon measure of borax and place it over the top of the assay. A little bit of distilled water dripped on top so that the powdered material does not fly out of the crucible when I apply the torch. Okay. I should be wearing gloves. I know I should be wearing gloves. This stuff can pop and fly out. Enough said. You shouldn't even be trying this at home. You shouldn't think about trying this at home. We get a little bit of fuel. Okay, for the first part of this, you want a real fuel-rich flame. Oh, put it out. But you need enough oxygen to be able to melt the sample relatively quickly. Now that's too much fuel. Back that down a little bit. Add a little bit more oxygen. A little bit more fuel, a little bit more oxygen. Alright. See how the stuff splatters and goes? Stuff is starting to melt. You just move your torch around. I'm adding a little bit more fuel to the mix. Starting to melt. Look at that wonderfulness. A little bit more oxygen. Here we go. Melting, 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 melting. Do not breathe the fumes or you will die. See, the borax is starting to melt. Starting to create slag. Now, you'll notice little metal beads forming. That is the lead from the flux. And what we're going to do is we're going to try and collect all of those little metal beads into one big metal bead. You can see it down in there. It's starting to get big. See it? There's our metal bead. Most of that's lead. Hopefully some of it's some wonderful stuff from the orb. Right? Melting, 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 melting. Getting this stuff going. Little metal beads. That's what we want. Little metal beads. Shaking it, shaking it, shaking it. Oh, now we have a bigger metal bead. But there's still metal clinging to the sides. Got to get all that metal out of there. Being aggressive with it, making sure all the little metal particles in there are melted. Melting, 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 melting. See, nice slag. Okay. Now, what I'm going to do is I'm going to pour the slag off onto the aluminum. So the purpose for the aluminum is that it causes the slag to cool almost immediately. There's my little bead that I want. Alright, now I'm going to try and pour my little bead away. Whoop, there it is, right there. I hope you can see that. That is not precious metal recovered from the material that we put into the crucible. That is a lead bead that contains some precious material, hopefully, if it's in the sample to begin with. Alright, we're back. That is extremely hot. I know that's obvious. It had molten metal in it. Okay. Our little metal bead. We're going to cover it with borax. The process that we're going to do now is called scorification. See, it's hot enough even at this point to melt the borax. To scorify is to drive off impurities. There's going to be impurities. Might consist of base metals, other components in the rock that you don't want to be part of your assay sample. And we're going to do this with an oxygen-rich flame. There's our little metal bead. It broke up, but that's okay. We're going to get it to reform here. There it is. It's got a little bit of blue on it. Those are the impurities that we want to get rid of. Getting rid of the impurities. Oh yeah, go away. Go away, go away, go away. Scorifying, scorifying, scorifying. Oh, see it? Oh, there it goes. Yeah. Get out of there. Now, same thing. There it is. Now we are going to cupel. Cupellation is where we burn off all of the base metals. And it burns off when you burn away all of the lead. You need to preheat this little crucible gently so that it doesn't explode. We do this with a fairly neutral flame. That wasn't something important. We have a little piece of slag stuck to it. Now there's something that's kind of important that's going to happen here. You start to notice a blue flame when it gets hot enough. blue flame coming out of the opposite side, basically to the 6 o'clock side of the torch head. Okay. That is lead being burned away, and with it, the impurities and base metals. When the blue stops, you turn up the oxygen just a little bit, get a little bit more heat. Okay, I can see blue. You can see it moving away from the torch head. It's just a little bit different than the orange. You keep going until the blue disappears. You may or may not be able to see this. That is the gas that is being released from the lead and other toxins and other impurities and base metals going bye-bye. It is extremely toxic. You cannot be anywhere near it when you breathe. I should build a flame hood for this, a fume hood. Blowing that little bead all over the place, it's making me really nervous. Normally this stuff sticks right to the bottom of the cupel, but it's not doing that today. Still have some blue, means we gotta keep going. All right. There it is, that's it. Obviously, you need to let that cool. This is an optical comparator. It is a 40x microscope with a scale that allows you to measure precisely the diameter of a bead, if there is a bead, in the bottom of the cupel. You can see the cupel. I got a smattering of tiny metallic beads in the bottom of that you can see with a 40x microscope. Usually the beads stick together to form one little bead that you can measure. The largest bead that I can see, little metallic grain is what it looks like, is 2/1000ths of an inch. I performed the fire assay procedure 3 times. You can see by the 3 cupels that the 2 on the left are quite a different color than the one on the right, and I believe that's from off-gassing. The cupel on the right had a bead, or more a smattering of tiny little beads that were too small to measure. The cupel in the middle had a bead that measured approximately 0.156 inches. It was silver in color and dimpled. The cupel on the left had an oblong bead that measured 0.07 inches. It was also dimpled. Normally, if the beads are made up primarily of silver or gold, they are generally spherical and smooth, indicating there must be traces of other metals in these beads. Thank you for watching the video. In the next video, which may be quite some time in coming, I will try and part these beads.